a coil. Okay, so now we are going to discussing about AC circuit containing L only, means AC circuit containing inductor only. Inductor is just a solenoid or just a coil. When a varying current or fluctuating current is passing through that inductor, a back EMF will be generated. That we studied when we studied when we studied about that chapter EMF. Okay, a back EMF. Back EMF means an EMF or a current will be generated inside the coil which opposes the change in current through that coil. That should be come in your mind while we are discussing this circuit. Okay, now we are going to consider a circuit. So I am going to draw a circuit. This circuit is containing, here is an inductor which is connected across an AC voltage. Okay, so this is the applied voltage. The standard equation for representing that applied voltage is V0 sine omega t, in which every terms we discussed in the last class, where V0 is a maximum value of voltage and omega is the angular frequency with which the coil is rotating. Then this is an inductor, so it's a coil. The self-inductance of that coil I am going to represent it as L. Okay, now we applied a voltage V0 sine omega t across this coil. So how much is the current induced in this circuit? That is we are going to find out right now. So when we are applying this voltage across this inductor, a back EMF will be generated inside the inductor. So the induced EMF will be equal to the applied voltage. So V0 sine omega t. Okay, actually we are just applying the Kirchhoff's laws here. So we are going to consider a closed loop, and then we are applying the Kirchhoff's mesh rule. When we are applying the Kirchhoff's mesh rule, we will get that E is equal to, where this E is induced EMF. What was the equation for the induced EMF in an inductor that we studied in the last chapter? L into di by dt is the equation for the induced EMF. So L into di by dt can be written as V0 sine omega t. From here, we want to find out the value for the current I. So we can write di is equal to V0 by L into sine omega t dt. So I is equal to, we have to integrate integral V0 by L into sine omega t dt. When we are integrating, we will get this V0 by L are constant. Then integral sine omega t is minus cos omega t by omega. That integration step right now I am not going to explain. So this is, when we are integrating, we will get it is V0 by L into minus cos omega t. This one can be written as I is equal to minus V0 by L omega into cos omega t. So this is the equation for the current. We are getting I as I is equal to V0 by L omega into cos omega t. Here we know that the applied voltage is V0 sine omega t. So the phase of the voltage is omega t. Okay, but here the voltage is represented in terms of sine, but the current we are getting in terms of cos. So to it means that there will be a phase difference between voltage and current. To understand the phase difference clearly, we have to convert this cos into sine. So I am going to write that current I is equal to minus V0 by L omega into, we know that sine 90 minus theta is cos theta. So this cos theta can be written as sine 90 is pi by 2. So pi by 2 minus omega t. Sine pi by 2 minus omega t. So, and in trigonometry, you might have studied another equation. If you are including this minus along with this sign, then minus sine theta is sine minus theta. When we are taking this minus, then we can write it as V0 by L omega into sine omega t minus pi by 2. And this is the final equation for the current, where maximum value of current can be represented by this one, V0 by L omega. Therefore, current I can be written as I is equal to I0 sine omega t minus pi by 2. This is the equation for the current in an AC circuit containing inductor only. I is equal to I0 sine omega t minus pi by 2. From this equation, you have to note two important points. One is the phase of voltage is omega t, and the phase of current was found to be omega t minus pi by 2. That means the voltage and current are not in the same phase. They are having a phase difference of pi by 2. Actually, it is not a pi by 2. This is a phase. Omega t is a phase of voltage, and omega t minus pi by 2 is the phase of current. Means current is lagging behind the voltage by a phase of pi by 2. That is important. Current is lagging behind the voltage by a phase of pi by 2. So what does that phase difference implies? That is I am going to explain now. Okay, so for that we will consider the same circuit. You just assume that initially some current will start to flowing along this direction. You just assume that initially the current is starting to flowing from left to right. We know that there is no fixed direction for AC. And when the current starts to increase from left to right, induced EMF will be generated inside the coil that will be in the opposite direction. That induced EMF will opposes this current. That induced EMF will opposes this current. Okay, now what happened? So as a result, for time being, for a short interval of time, there will not be any current flowing from left to right. After some time, we know that the AC voltages will increases from 0 to maximum. Then the AC voltage will starts to decrease. So actually, the applied voltage is trying to produce a current in this direction, but back EMF is produced there. After some time, the applied voltage gets decreases. So the value of this one will starts to decrease. At that time, the back EMF will be more. So that will produce some current through the circuit. So that in that way, we can understand that there will be a lagging between voltage and current. Okay, so that is happening in the case of AC circuit containing inductor only. So last class we studied one circuit. It is AC circuit containing resistance only. In that case, when the voltage increases, along with the increase in voltage, current will also increases. But in this circuit, it is observed that when the voltage increases at that time, for a short interval of time, there will not be any change. In that way, we can say. But when the voltage starts to decrease, the current will start to increase. Okay, that you will understand more clearly by drawing a graph. So now I'm going to draw a graph between here is I'm going to draw omega t, and here is V or I. First, the AC voltage will looks like this. And this is omega t is equal to 0. This is omega t is equal to pi. And here is omega t is equal to 2 pi. And here is omega t is equal to pi by 2. And here is omega t is equal to 3 pi by 2. So this graph implies that as the time increases, voltage increases, then voltage decreases. So this is the standard equation of the voltage applied across an AC circuit containing inductor only. The applied voltage is V0 sin omega t. But now I am going to draw the current flowing through an AC circuit containing inductor only. The standard equation for the current is I0 sine omega t minus pi by 2. That means when omega t is equal to 0, the current is I0 sine 0 minus. So it becomes, when omega t is equal to 0, this one becomes sine minus pi by 2. Sine minus pi by 2 is minus 1. So when omega t is equal to 0, the voltage is 0, but at the same time, the current is minus 1. And when omega t is equal to pi by 2, you substitute here, the voltage becomes V0 sine pi by 2, and the voltage becomes maximum, that is V0. But at the same time, the current is I0 pi by 2 minus pi by 2, because when omega t is equal to pi by 2, this omega t minus pi by 2 becomes 0. So that time the current is becomes 0. So the graph will starts from here and it will moves like this. Okay, so this is the graph for current flowing through a circuit. So this graph implies that there is a phase difference between these two values. That means there is a phase difference between voltage and current. Okay. So in a simple way, you can understand like that. When the voltage increases, along with the increase in voltage, current will not be increased. Current will starts to increase when the voltage starts to decrease. So there will be a phase difference. But in the case of a resistance only, that's also we discussed in the last class when we discussed about the value of AC circuit containing pure resistance only, there is no phase difference between voltage and current. So the voltage and current will simultaneously increase and simultaneously decrease. But here there is a lagging between voltage and current. And current lags behind the voltage by a phase difference of pi by 2. Now, last class we were discussed about the phasor diagram also. Phasor diagram, we discussed that it's a vector diagram representing the phase difference between voltage and current. So now here we are going to draw a phasor diagram. Now initially I am going to draw the voltage. The phase of voltage is omega t and the maximum value of V0. The vertical component of this V0 will be V0 sin omega t, instantaneous voltage. This is the phasor diagram representing the voltage. Now the phasor, if I want to draw the phasor diagram of current, then the standard equation of the current is I0 sin omega t minus pi by 2. So the phase of voltage is omega t. That is why from x-axis I drawn an angle of omega t. Then I drawn the V0. And normally, if an angle is measured along the anti-clockwise direction, that angle will be considered as a positive angle. And if an angle is measured in the clockwise direction, that will be considered as negative angle. Okay, that is the direction of an angle. Positive and negative of an angle means it. If angle is measured along the anti-clockwise, then it will be considered as positive, and clockwise it will be considered as negative. Now, I'm going to draw that voltage. Here omega t is the angle for voltage. Now omega t, from omega t, if I am measuring 90 degree along the anti-clockwise direction, that angle will be omega t minus pi by 2. That will be the angle or phase for current. So the vector diagram representing the current will looks like this. So from this diagram itself, it is clear that the angle between voltage and current is 90 degree. So there is a phase difference between voltage and current by an angle of 90. Now, if the current is above the voltage, then we can say that the current will lead. But here, the current makes an angle of minus pi by 2 with the voltage. So current is lagging behind the voltage by an angle of pi by 2. So this phasor diagram is important. Then phase difference, how much is the phase difference, that is important. Then another important thing is, here we know that the applied voltage is V is equal to V0 sine omega t is the applied voltage, and the corresponding current what we are getting, it is I is equal to I0 sine omega t minus pi by 2. Now, this I0 is the maximum value of the current flowing through the circuit, and I0 is written as V0 by L omega. Okay. Now, as per Ohm's law, I is equal to, what is I? I, according to Ohm's law, I is equal to V by R. Okay, it is V by R, where V is the voltage and R is its resistance. Here is also, this term implies that I0 is equal to V0 by L omega, means L omega is a term which is having dimension equal to the dimension of resistance. Or in another way, we can say that this L omega is simply the resistance of that inductor. But it is wrong. If we are saying L omega is the resistance, then it is wrong, because inductor is a coil, and that coil is made up of a conductor. Conductors, normally we are studying that the conductors is having no resistance. But this L omega is the resistive effect here. So that is why this L omega is known as reactance, because it is not resistance, but it is resist the current. It is actually not the resistance, but it resists the current. So that L omega is known as reactance. And that reactance is also known as, since it is that reactance is produced due to inductance, so that is known as inductive reactance. This L omega is known as inductive reactance. It is denoted with the letter XL. So XL is equal to L omega. And that should be taken care. Why we are not saying it as resistance? Because that inductor is made up of conducting material. So that will the coil or material which is used for making a coil is a good conductor. So it will have some resistance, but almost its resistance is considered to be negligible. Okay, but still it opposes the current. So, or in another way we can say still it opposes the change in current flowing through that inductor. Still it opposes a change in current flowing through the inductor. That ability of the inductor to opposes the change in current is known as inductive reactance. Okay, or a simple way we can say that the resistance of inductor is known as inductive reactance. So the unit of XL will be ohm itself. But it should be noted that if frequency is 0, what will be the reactance there? Inductive reactance. If omega is equal to 0. Omega, we know that in small classes or in class 11th, you study that omega is equal to 2 pi f. We know that omega is equal to 2 pi f. If we are using this equation, then we can write XL is also is equal to L into 2 pi f, where f is a frequency. So if the frequency of the applied current is 0, frequency 0 means the current is not changing. For example, instead of AC, if we are connecting a DC, current from a battery, then current from a battery is constant. There is no changing or oscillating. So its frequency is 0. If the frequency is 0, what will be the reactance here? As per the
L.
equation. If frequency is 0, then XL is equal to
0.
Zero.
L into, yes, it is L into 0, so it becomes 0.
Yes, sir.
That means, correct. That means the inductor will not opposes the DC. So if a constant current is flowing through it, it will not opposes DC. But if a varying current or AC is applied, then depends on the frequency that inductor will have high resistance. That means inductor will opposes AC, but inductor will not oppose DC. Got it? But if it is a resistance, that resistance will opposes DC and AC. Same time, resistance. If it is a resistance, then it will opposes DC and AC, correct? But inductor will not oppose the DC because the reactance of inductor depends on the frequency. As the frequency increases, the reactance increases, and as the frequency decreases, the reactance decreases. Got it? So that reactance depends on the frequency. So normally this coil, inductor coils are used in AC circuit for reducing the current flow through the circuit. In DC circuit, if you want to reduce the current flow or if you want to produce some potential difference, then we are using resistance. Normal resistance will use because resistance will oppose the current flow. But in AC circuit, instead of resistance, normally we will use this reactance. Sorry, inductor. Can you say why? If we are using resistance also, we can get the same effect. If you are using the resistance, that will also oppose a current. But in AC circuit, instead of resistance, we are using this coil for opposing the current. Because if we are using resistance, then it is having some strong opposition against all the type of current. So some amount of energy will be lost in the form of heat. But this inductor is made up of conductor, so less resistance, so no heat energy loss there. So if we want to reduce the current, then we will use that inductor. Then how it reduces the current? That is by back EMF. So last class we studied one more equation for the energy of an inductor. There we studied that Inductor stores the energy in the form of magnetic field. So it opposes a current, but that energy is not wasting. That will be stored in the form of magnetic field, and in the next half cycle, that energy will be used. Okay, so that is also an important question. Why inductor is used in AC circuit to reduce the current than that of instead of resistance? Or what is the advantage of inductor in AC circuit than that of resistor? What is that? If resistance is used, then it may produce some amount of heat energy. But inductor is not losing any type of heat energy. But this inductor cannot be used in a DC circuit for reducing the current. Why? In DC circuit, the frequency is less, so no reactance. Or in another way, we can say that in DC circuit, there is no change in current. So no back EMF will be there. So it will not oppose the current. Got it? So when we are studying this diagram, when we are studying this circuit, these points are very important. Once again, I will just revise, give a quick revision. Okay. So what are the points, especially in term 1, you are going to attend the objective type questions. So the points you have to be noted, the circuit diagram. First one is the circuit diagram. How AC circuit containing inductor looks like. Then when a voltage V0 sin omega t is applied, so the applied voltage is V0 sin omega t, phase of voltage is omega t, and the current we are getting I is equal to I0 sin omega t minus pi by 2. That is, equation is important. I0 sin omega t minus pi by 2. Therefore, the phase of the current is omega t minus pi by 2. So that is the next point. So there is a phase difference between voltage and current with a phase difference of pi by 2. There is a phase difference between voltage and current of pi by 2. And the current lags behind the voltage. That is another point. Next point, current is lagging. Okay, here voltage is leading, current is lagging. Now the maximum value of current is I0 is equal to V0 by L omega, where L omega is known as inductive reactance. And inductive reactance depends on frequency. How it depends on frequency? As the frequency increases, inductive reactance increases, and as frequency decreases, the inductive reactance decreases. Then the phasor diagram, how the phasor diagram looks like, and the normal waveform. So these three diagrams, circuit diagram, waveform, then phasor diagram, then phase difference, inductive reactance, and how it depends on frequency. And what is the advantage of this inductor over a resistor? Okay. Any doubt?